Hey, Scott, welcome to Mass Construction Show.
Hey, Joe. Great to be back. Thanks for having me.
Yes, this time in person, which is nice.
Yes.
Unfortunately, we were in a COVID world. Was it COVID world? That's why we were remote? Or
End
was
of
it
COVID
just
adjacent for sure. Yeah. Getting back to regular life. But yeah, great to be here.
Yeah, it was funny. There was like a hangover where I was doing, kind of kept doing remote because it got started. But as of late, I've been doing a lot, almost, 90-something% of them are in person. And
yeah, it's very welcome. We even do meetings now in person again. It's nice to get back out in the real world and see people rather than, Zoom fatigue and that sort of thing.
Yeah.
So.
And the conversations are just a lot better. There's more, like you're more comfortable ahead of time just kind of chatting about things versus if you're on a screen, you're like, okay, let's get started, yes. Right? So that's nice. I'd like to preface this conversation. Today we're going to talk about digital electricity. Mm-hmm. You are not claiming to be an expert on digital electricity.
Yeah. This is not a course where we're going to give somebody credits for or certify anybody on this by any means.
Yeah, exactly. And, I look at these like cutting edge topics, and I think usually there's very few people that are experts on it because they're so new. Sometimes I call them stretch episodes where people are like, well, why are you talking about these things if we're not doing them right now? But it's just to get you to think about, hey, where are we going as an industry? Should you learn more about it? Hey, if this happens, then what happens? What does that mean for everything else? So it's just an opportunity for people to start thinking about, hey, what's coming? What should we be learning about? What does the future of our business look like? And then you can make decisions accordingly. Maybe you might say, hey, I'm in a niche of a business that, might be declining or dying, but this is an area that could be a whole new industry. I'm not saying that's what this is, but whenever we discuss these topics. So at this point, I'm just hoping for you to give us like a high level understanding of digital electricity. But before we do that, I already referenced our past episode. Our past episode was on power over Ethernet. Mm-hmm. Could you do two things? Give us a background of kind of where you came from so we understand your perspective. Yep. Just a nickel version's fine. And then a little bit of a refresher for power over Ethernet for people that either forgot because it was a while ago or aren't aware because it ties.
No, it's a great starting point on where we're going for sure. Mm-hmm. I think it was not quite a throwaway line, but it was, just something said almost in passing when you and I were speaking last, and now has kind of developed into a fun topic and a fun thing to look at. So I'm the division manager for our low voltage division at Gaston. We oversee all things technology related and telecommunications, AV, security, wireless. I've been in the industry for 16 years, and it's like what I started in and made my bones. And in that technology space, technology keeps evolving. It keeps improving. We see it in everything we do and everything we touch in our daily life and professionally now. I want to know what the latest and greatest is. In some cases, it makes things redundant and they phase out and a new technology and a new way of doing things takes its place. Sometimes it just makes a way to do something a little easier, and it's a great application-specific advantage. So both PoE and digital electricity, I think, have a place currently, application-specific. Can they evolve towards something bigger and better and a new way of doing things as we look to keep progressing and building new buildings and taking on new projects in the future? Totally possible, right? Mm-hmm.
Yeah, probably likely. So power over Ethernet is the distribution of power and information over low voltage cable. Can you give us a little?
Yeah, you can transmit power to edge devices. So if you have a wireless access point, a camera, if you have a printer that can take PoE, you transmit the power over a 4-pair Ethernet cable as opposed to running line current out to wherever you're doing it. It's a labor savings. It's an efficiency savings. If things are on the network, they can be monitored. If you're trying to track some sort of usage or ROI component to it, it allows for all of that using the same structured cabling principles that are in place currently to provide the data.
Okay. And it's safer.
Yes.
Right. Because you're dealing with low voltage.
Correct.
Could you use PoE, power over Ethernet, if it didn't have a data component? A lot of times it is data driven, but could you use it just for power?
Yeah, you can. And a lot of they have cameras now that's the way to provide power to them most efficiently. but they also have a Wi-Fi component. So you can run a pair over there. The only generating source point would be out of a switch. So if you're already connected to a network switch, you're likely managing the data on that as well. But it is possible. You could just power through there. They make PoE injectors that you can plug into the wall and pick up out of a standard circuit and then run through over a 4-pair cable. So that is an option as well. And then you can use the Wi-Fi to gather whatever signal you're trying to do.
It's almost like just an adapter you can plug in the wall.
Correct. Yeah.
That's pretty good.
Yeah. It's a nice way to extend it. And like I said, these remote things, the intent of it is not to replace line voltage electricity, but on an application specific, if you're putting a camera out at the edge of a parking lot, or if you have a wireless access point that you need to deploy and it'd be cost prohibitive to rip up the ceiling and put a bunch of, cabling and conduit everywhere, it's another great option to provide power where you need it.
I love it. And then in reading and our discussion, it's starting to appear like, especially as the equipment gets more efficient, like I'm hearing things like VAV boxes being powered by...
Yeah, the lighting is always on the cusp of it, and that's what everybody thinks of when they think PoE now. Kind of comes in and out depending on products or manufacturers who take an interest and dive in and focus on it. But yeah, certainly VAV boxes. Anything you want to put a sensor to, especially in the building automation side, has a component or a capability to be powered by PoE. So you're only running one cable to it as opposed to multiple.
And with traditional electricity, what's kind of the limit for PoE from a power perspective?
Typically, it's 100 watt is the max capacity. There are devices, and it generates off of your switch side. So if you have a port that can produce 30 watts, that can do a camera, it can do a wireless access point, some smaller devices. If you have a switch that has a higher capability, it can go up to 100 watt. That's the limit on the standard right now. Okay. And all of that's inside of 100 meters, like 328 feet.
Yeah. So you're running a mix of what's physically capable and then also what's allowed by code.
Correct.
Right. So both of those are kind of governors on what you can do.
Yeah. You have a wattage limit, you have a distance limit, and then what devices can actually accept that. So,
okay. All right. Now, digital electricity. What is digital electricity?
Digital electricity.
I've read it and I was just like, I don't know how I would explain that to somebody. But
so it is branded. It is a trademark of a particular company, VoltServer, who makes the product and the transmitters and receivers for it. But it's a way to send electricity packetized across a longer distance, and it's a safer load over that lower voltage class 2 cabling, similar to like PoE cabling would be. So if I'm stuck by 100 meters and I'm stuck by 100 watts, digital electricity can blow right by that, and you can do much higher wattage, 2,000 watts, and you can go much further over the same low voltage cabling. So it still removes the mandatory need for line voltage and all that entails, cabling, conduit, transformers, step-down gear. It takes away a lot of that, and you just have a transmitter on one end, a receiver on the other, cabling in between, and the safety component is what, and I think we're going to talk about it in a little while. With it being packetized, the same way I send you an email, it gets broken down over bits and bytes and reassembled on the other end for you to understand what I'm saying. That's what it does with the electricity. So if I touch the cable or it comes into contact somehow, it stops the transmission point. It gets reassembled on the other end. It doesn't just, you don't lose connectivity, but it doesn't transmit live current the same way AC or DC would.
In reading it, the way they referred to it as packets, like you said, packetized. So each packet has a certain amount of, what's the right word? Electricity, current? Like
very minor voltage capacity on it. It's not anything that if you did touch it would do anything to your body, no kind of impact from a safety standpoint, times thousands of packets throughout the cable. So
and it was saying that each or millions, right? Billions of packets, right? So there's all these tiny little voltage packets that are getting sent through the line, and I think they said like 0.3 milliseconds or something like that. They monitor it. So after each packet leaves, it's monitoring. So if there's a break in the line or something like that, it shuts it down. So that's how the electricity is traveling versus I'm so bad at electrical, so this is way out of my league, but where you would have like the alternating or AC/DC kind of thing, where it would just be kind of continuous.
Correct.
Or kind of a wavelength of electricity.
Yeah, and if something interrupts that, it's sending the current directly into what interrupted it. And totally.
Yeah, where this is chunks of electricity, and it's being monitored after each chunk and then just breaks it rather than letting it just continue to flow through.
Exactly.
So that's the kind of how of that works in layperson's terms, right? And then there's the second piece, which is, okay, currently, if you were using, Cat 6 cable, like you said, you could go 100 meters or whatever it is, 100 watts and 100 meters with traditional current, if I'm using the right word there. By having digitized electricity, now instead of doing 100 meters, you can
extend everything. Yeah, you can extend the wattage, you can extend the distance, and it allows you to go further, higher. And it's really, what does this enable? And that's, I think, why we're talking, why it interests me and why it interested you when we spoke it up. What can I enable now with this technology in place that makes installation easier, communication easier? What can I monitor? All those kinds of things are now available.
Yeah. So I was looking down because I was looking at this chart where it talked about PoE and 70 watts and class 2, which would just be like traditional wiring. Right?
Yeah, low voltage wire, like an 18.2 and 18.4 type cable.
Okay,
yeah.
Great. That would get you 80 watts. And then when they're talking digital electricity, depending on the wire gauge, you have 300 watts, 600 watts, 1,000 watts over 1,000 feet, 15. So in this case, so it says 4 pair 18 AWG would get you 1,000 watts over 1,500 feet.
Yeah, all low voltage, no need for conduit, no need for additional transformers. You don't need to build out extra equipment in an electrical closet. And like it's the application and what it allows you to do. I might be stepping ahead a little, but where it's built into, they use it a lot for DAS systems, distributed antenna systems, giving you like a 5G signal in a stadium or large venue. You're putting antennas in places where it's kind of hard to get to, and it's definitely hard to run cabling and conduit, and you're not going to put a transformer on the roof of Gillette Stadium. You know, they have equipment rooms, but if you're going to outfit all these extra devices and all this extra load that would normally be put on back to the panel, you run everything over digital electricity. Now you can power those off of a receiver and a transmitter. All the cabling is low voltage cabling. They make it where it can be outdoor rated. They make it where it can be plenum rated if it needs to be. And then it gives you flexibility in installation, and you don't have to have that incurred cost.
Have they gone to like an MI cable if you need it?
They haven't yet, but it certainly can be. And
yeah, be in a matter of no time, right?
Yeah. We see it, and it has a fiber component to it, and like fiber optic cabling for a backbone in a building does the same thing, where now it's armored, and that takes away that need for it to be in a conduit. Certainly an option, but not a requirement for functionally how it works.
Yeah, and if we're talking 1,000 feet even, but they're talking 15,000 feet, you could have a 60-story high-rise with a 200 wide footprint floor, and you can go 1,000 feet.
Yep. Yeah.
Right? And you could just run it from the basement up to the 60th floor.
Yep. Yeah. When we do a commercial installation for a building, and if we're doing a coring shell, the horizontal cabling is, everything on each floor, providing whatever devices they want to power up with. But the backbone infrastructure is always fiber, because you can go a longer distance through the fiber optic cabling and transmission. This is kind of no different in that the digital electricity allows for that longer distance. It can almost be the backbone, if you will.
Yep.
And then you can convert back over on each floor. You put in a PoE capable switch. You could then have PoE powered devices through there. All of that's a digitized version of electricity outside of your standard panels and meters and feeds everywhere. Yeah.
So you're saying you're doing that Ethernet now out of a backbone, and that's for powering card readers and cameras and all that kind of stuff.
Yeah, we will do for PoE devices that we install that day in, day out, and security applications, like wireless applications, very commonplace, and that's how a lot of those devices end up getting powered now. The digital electricity piece, it's not really in play yet, where it has the functionality of being an everyday occurrence or on the tip of every engineer's tongue. But it has that capability, and it has that inherent technology built in to exist.
Yeah. And it's currently has been used in quite a few places, right? A lot of like train stations.
Yep. I think large
stadiums.
venues, anywhere a lot of people are, right? You're putting a lot of, again, it's mostly around DAS systems. So you're putting a lot of antennas in a lot of wide area coverage places.
Yep.
It's a great place for that.
So could you explain just DAS real quick?
Yeah. So distributed antenna system, if you need cellular service and you walk in and Verizon's not working, or I got spotty T-Mobile, but you have AT&T and you're good. Buildings, building owners, property management companies, there's a real business in providing connectivity and coverage to everybody.
Kind of like a repeater.
Yeah, it actually is a signal source that gets brought in from the carrier.
Yep.
And then an antenna system that gives everybody service from that.
Oh, nice.
So,
so if...
Yeah, repeater would be there's existing,
and you're trying
it
to
works
boost
outside Gillette,
that.
but when I'm inside Gillette, it doesn't work out. That repeater system will boost that signal. But no, a lot of times they'll bring in a source. They'll have head-end equipment that Verizon and T-Mobile and AT&T all participate with, and then send the signal out where when you walk in, there's no drop-in coverage. And if you need to call 911, there's no drop-in coverage and they can't tell where you're at.
And all those carriers will use that backbone that gets installed?
Yeah, typically it's still structured cabling for the most part, but there has been many use cases for digital electricity where they've used that as the transmission point to power those antennas and to give those antennas a feed to transmit back, for sure.
Okay. So if digital electricity takes a foothold, it moves from you doing your backbone and running all your cameras and card readers and whatever else into, and actually you could do certain light fixtures now, but it would be that you could do outlets, you could do...
I don't know that it would fully take over the building's, electrification and how a building is powered. A lot of it will depend on what devices you're looking to do. If you want a sensor point, I think if it's moving to a building and, as things become more converged network or smart building capable, you need sensor points everywhere to continue to monitor that. Otherwise, how do you know systems are functioning like you want it to? How do you know you're getting the ROI you're looking for and looking to capture? If you're looking to put stuff on the network, it makes all the sense in the world because it's the same type of cabling that you would need to grab those sensors and grab that data out of, while you can also deliver power to them.
Yeah. When does it make sense to just be power?
Yeah. Larger scale applications, larger current sizes, or you're trying to go through. And sometimes it's just ease of efficiency if you're building out and, you have these circuits in this area of the floor and I have these circuits in this area of floor. It's still probably a little more efficient to run that way, especially if I don't have a lot of devices. We're only putting in a few wireless access points in an area. It's only going to power those access points and it wouldn't give me power for anything else. You'd still need traditional current.
Okay. And then you also see them touting some of the benefits being lack of power drop or voltage drop over distances.
The packetized part of it allows for, there's no spike in current. If you interrupt AC or DC power, you have an instance that creates a spike. There's some sort of thing to it. Packetizing it spreads it out over, like you said, millions, billions of packets. There's no surge in there. It gets assembled on one end, disassembled on the other, and it evens out that load.
And that allows for lack of voltage drop over...
Correct. Yeah.
Or not even necessarily the up and down. I thought I was reading that they were saying there's an inherent voltage drop over longer distances that doesn't happen with digitized.
Yeah, because when you break it apart and you can send it further, reassembled on the other end, it's the same size it was on one end as it is at the receiver end.
Oh, I get. Okay. Yep. Because you're sending bundles rather than.
It's not starting out as a snowball that ends up down as a little.
Yeah, I was going to use the water now. Yeah. Okay. That's interesting.
Yeah.
Okay. So it's just you're sending those packets. So they start, the packet is one size and
Yeah.
it comes out the other, it's the same size.
A nanobyte of some size here. It's that same size at the other end, at the
Interesting.
receiver side.
Okay. And now, what are the components if you were to use digitized electricity? So you get normal power coming in off the street at a high voltage.
Yep.
Does it hit a transformer?
Yeah, so they'll still go through a transformer. Everything will house in some sort of room with a head end. Typically, it would be like an MDF or some sort of building where all the equipment, or room in a building where everything would house. From there, it'd go through a traditional, the same things we install now, like a UPS, uninterruptible power supply, a PDU to kind of monitor the load going onto each switch and device. And then from there, it goes into a transmitter. The transmitter will look a lot like a switch. It, rack mounted, kind of sits in the same equipment housing that a lot of our network equipment would right now.
Okay.
That's where it turns into digital electricity in that, and that's,
So is that, you said it's a transmitter?
Yeah.
So that transmitter is acting like a transformer, not that it's bringing it up or down with voltage. It's just reconfiguring.
As I understand it, yeah, it just reconfigures and makes it where it can digitize and packetize that load.
Okay. So that transmitter changes it to digital electricity and then distributes it to where?
At the other end, there'll be a receiver. The receiver takes that, reassembles it, makes it coherent and like usable power at that point, and that receiver will then go out to whatever the device is.
Okay, so when it's traveling from the transmitter to the receiver, the electricity is structured one way, and then when it leaves the receiver and goes to the edge device, it's configured another way?
I don't know the exact capability of that, but I think you can choose whether you're asking if it's going to be like AC current versus DC.
Yeah, or I just didn't know, will it ever be digital electricity all the way to the edge device and then right at that point get converted back to AC/DC, or it has to be?
No, it should be after it goes through. It needs to stay digitized from transmitter to receiver. Otherwise, you would lose it and there would be nothing to reconfigure it on the other end. But when it comes out the other end, I actually don't know exactly how it connects to that device.
Okay. So from the receiver, which would, let's say you had a receiver in a function room where there was, multiple cameras and speakers and whatever. You could run from the transmitter all the way to
where the receiver
is.
And then from there, branch off to power devices. Yeah.
And it's going to be normal electricity at that point. If you touch it, you're getting zapped.
Yeah, there should be some play in where it goes back into like almost like if you think of a network switch and multiple ports available, and then they come out and you power devices from there.
But actually, would you still be, most likely it would be PoE?
It's a way to think of it, yeah.
From the transmitter.
Yeah, on the receiver end.
Yes,
yeah.
from the receiver to the device would be power PoE, so it would be low voltage anyway.
Yeah, it's a low voltage current for sure, yeah.
Okay, so digitized, it's safe from the transmitter to the receiver. Then from the receiver to the edge device, it's low voltage, Cat6 cable, Ethernet cable, whatever, to that device. So at any point along that line,
it stays in low voltage classification.
And it's safe.
Yeah, correct.
Okay. So my next question is, as this gets more widely adopted, do we end up with a safer
I think
industry?
Safety is one of the biggest selling points to it, right? Distance and safety are probably the two biggest advertising points that they make on this, and why you would accept it or look to utilize it, right? So if that's the case, and I know I have an inherently safer installation and inherently safer connection from point A to point B, totally. Yeah. I don't think it's going to completely like go away where it's not something we monitor, and it's not mandated by OSHA for certain requirements. But yes, it's an inherently safer product by it being low voltage and by the way that it's transmitted.
I mean, right now you always hear it. It's Focus 4. It's one of the top 4 every single year.
Yep.
And I think in the pre-bubble wrapped world, it was the fatal 4 because they were the 4 that killed people. So it's a common occurrence, electric shock, in some cases, pretty heavy fatalities. And it's funny, Eric Richmond does an NFPA 70E class for me. And it's interesting to see, you saw the fatalities dropping with electrocutions. But now we've kind of plateaued. And we always have a discussion around like, okay, what was causing that drop and what's been the plateaus? There was probably a mix of technology, knowledge, better PPE. I mean, that could be technology, right? And then we've hit a plateau. So, does technology again get that drop? Because we can, I'll try and put that chart up. I'm going to make a note. Electrical safety chart. I'll throw it up on Instagram and LinkedIn or whatever. And we've made drastic improvements on electrical safety and fatalities. Even if 20% of the market goes to digital and PoE.
Significant savings, if you will.
If that's a 20% reduction in that number, people would be celebrating.
Absolutely.
Right?
Yeah.
So I think it's exciting on that front. I think it potentially changes to an equal extent how we build. Like, does it need to be a licensed electrician anymore? Can an apprentice be installing this stuff without a licensed electrician? I think the answer is yes. So it could be a big impact on the industry.
Agreed. Yeah. The way we do things now is not the way we did things 10, 15, 20 years ago. The way we're going to do things in the future, obviously, we'll adopt. This should allow for flexibility, function. If it's designed properly, you can achieve a lot with it already. And as it evolves, as it gets better, as technology even improves it more, you would think like there'd be some sort of flexibility on where it's going, who's installing it, how it's being put in, that we'd like to think we can capture on like really efficiently.
So you mentioned safety and travel distance being one of the 2 big selling points.
Yep.
I would say if anyone has heard us talking about the new energy codes, plural, as well as local ordinances here in Massachusetts, as I understand it, you're more efficient with digitized and PoE.
Very much so. Yeah. If you're checking your carbon footprint and you need to show reductions and you're interested in capturing that data to say, hey, I'm compliant with these rules and regulations, and those have real milestone dates coming up, right? You need to plan for them now before they come on board. A lot of that is around, if you have the technology to capture and show that data, then you can show compliance or track how you're compliant a lot easier. And this and PoE have that capability built in because it's network based. There's a monitoring component to it. You can, control and extract what you need from that. But from an inherent, point A to point B, you're reducing a lot of what you needed before. If there's no conduit in place, if there's not a transformer in place, that's reducing your footprint and your carbon load right there.
Yeah. So two things. I want to put it back to back. I just recently recorded with Mark Scow from Elevate Design. I forget if he's Elevated or Elevate. I should know that. Sorry, Mark. And they do a lot of design for like battery systems and things like that, and just energy efficient mechanical, electrical. They do all the MEP disciplines, but they really that's their little niche. And one of the questions I asked him is, in this new energy code and Berto world, are we going to see like a lot more sub-metering to really drill down. Because if you're having to pay a penalty based on your usage, and you've got an office building with all these people in it, and even if you don't, even if you just have a lab that you're using yourself, and okay, we're over, but okay, what are my energy hogs? Is it the fume hood? Is it the autoclave? Like where is it? It sounds like that's the answer to the question that, Mark wasn't 100% sure.
Yeah,
of the answer.
The monitoring piece is huge, and there's companies that like that's their niche industry is they'll do the monitoring and slap a sensor on everything that possibly can be and give you data back on where your pain points are, or are you running efficiently because your building isn't fully occupied, and can you make reductions on that? Digital Electricity and the Volt Server company have some built-in monitoring on that already. So if that's what you're deploying, you can use their monitoring. It can integrate in with other BMS systems and, continue that. That gives you the data to capture back exactly what you're saying. Where's my pain point? How can I mitigate it?
And it sounds like it's more efficient as well.
Yes.
So you're using less, you're knowing where you're using it.
Yes.
So from an efficiency standpoint and tracking standpoint, it's great. From a travel distance, it's great. From a safety standpoint, I'm saying great. They're the selling points.
Correct. Right? Yeah. The why is all of those things.
As far as I know, this could be the worst thing in the world, right? But we're making an assumption here that this will be what it says it is.
A fun revisit 6 to 8 years from now to see where things have gone to, and
agreed.
How much we said wrong versus how much we said right, and
and maybe we might laugh at each other. Hey, remember when we thought there was going to be digital packets flying everywhere, right?
Either high cringe factor or a lot of high fives.
Yep. And then the last piece you kind of touched on it is, I guess, just the sustainability, like less material needed, like you said. You're not putting conduit, you're not using heavy gauge copper wire. You're not, like you said, not using transformers or whatever other,
bringing in a crane to drop a transformer in on the top of a building, or all those things have the capability of getting reduced from that. Absolutely.
So cumulatively this all kind of adds up. Now you just mentioned Volt Server and what they sell as a product. I saw that there was another, JML Wireless or something like that also does
there are other products out there. I more reference them. We've been using the term digital electricity a lot, so don't sue us.
But that's a proprietary name for
that's their trademark for their
Volt Server
breakdown of that, correct?
Right? Does the fact that it is proprietary limit how widespread it's going to
get? You would certainly think that's a possibility. In the PoE world, I don't know that we really broke it down, even though we did a pretty thorough breakdown of PoE. Cisco invented that, and Cisco developed it for their phone system. So voice over IP became a thing, and then it branched off from there. Now it's proliferated everywhere, and people make cameras that are PoE enabled. All these different switch manufacturers that aren't Cisco make switches that are PoE capable. It is now a standard and built into the TIA code for what they'll allow for. I think that'll continue to evolve. Standards will exist and will define what it is, and then other companies will develop out of there that have a similar technology function to it.
So it's what's the word I'm looking for? It's trademarked or whatever the right word is, patent. When that patent expires, then like generic drugs or whatever, it's okay, it's in the public sphere. And then at that point, maybe it really...
Absolutely. Or off. Somebody finds maybe even a better way to do it, or a different, the Coke versus Pepsi of it, and a slightly different formula on how they do it.
I was just about to say, I'm sure Volt Server is already looking for the next way to improve that product. So they can then either extend their patent or have a different patent. And
correct. And new technologies, like I said, it's got applications currently that it's used in now. It's got applications that they advertise they can be a part of, but are growing into. We're still not, it's not quite bleeding edge, but it's leading edge for smart building and converged network capability. As that becomes the commonplace backbone of a building and how things communicate to each other, that opens up that possibility a lot more.
Yeah, because I'm sure they're going to have an inherent advantage.
Yes.
It's not a guarantee, but they've got an advantage because they're going to have all this time too.
Being first in the market can be great, can be a little rough at times, I'm sure too. But
Yep.
yeah.
But I'm sure they're collecting data about how to do it most efficiently. And, so it will be interesting to see how that actually plays out. Now, it's funny. We said this was going to be a short 15, 20-minute just explainer on digital electricity, but I'm not sure how many minutes we're at, but we're way over that.
Yeah.
So we can probably wrap at this point, but I want to ask the normal question, which is, over the next 2, 5, 10 years, you pick, what do you think we're going to see more of? And what do you think we'll see less of? You can answer both. You can answer one or the other. It's really up to you.
I think we'll see more places where technology is driving an adoption towards either PoE or some sort of digital electricity. Like I said, the flexibility it gives you, if you're putting a bunch of devices up either on the floor of a building or on the top of stadium or some sort of large venue, and you got to deploy all these points. How are you going to bring power to them? How are you going to get data from them? It gives you that flexibility already. So we'll continue to see that. That'll evolve. That'll get higher. If things evolve where they start increasing the load capability, or you need to capture a larger scale thing, refrigeration or something else like that, that's the next wave that we're not at yet. It'll be interesting to see if it goes that route.
And understanding that you're far from an expert in this, but do you think it becomes like large scale distribution ever? Like where the high voltage lines are now digital?
Not anytime in the near future would be my best guess towards that. I think it certainly has that possibility, but that's a big hurdle to clear over and make that shift. Yeah.
It would be interesting. Okay.
That's when we get our flying cars. We'll be doing that.
Yes. All right. Awesome. Scott, great as usual at this point. This is awesome. Appreciate you.
Thanks for having me. A lot of fun. And like I said, this will be fun to look back on in the future and see exactly where we were at and what we were wrong. But that's the fun of technology, right? Like it's all new. You kind of speculate on where and how you can use it, and things will get better and keep evolving. So it'll be fun to see how we did.
Couldn't agree more. All right. Thanks, Scott.
Thank you.